In this video, let's look on how to calculate molar mass for an unknown substance. So remember that when we write the unit for molar mass, it is the number of grams per mole. And if you notice, this is a derived unit, so it is actually a mathematical operation. It is grams divided by moles. Now, typically what we do when we come across a problem that deals with mass is we look on the periodic table and we add up the masses of the compound or the element in order to make our conversion. But let's say we have some substance and we don't know what it is, okay? So let's say you have an unknown substance and you know that this substance has, there are 5.2 moles, and you put that substance on a scale, and when you put that on a scale, it weighs 273 grams. And given this information, we can actually calculate what the molar mass is just by using this idea that grams divided by moles gives you the molar mass. So all I have to do is I have to take this and divide by that number, 273 grams, divide by 5.2 moles, and divide it. I get 52.5 grams per mole. Okay? And we don't know what the substance is, but now we know what its molar mass is. Okay? Now let's try another one. We could also use this to identify, say, an element. Okay? So let's say you have a silvery metal on a scale, and the scale says that it has a mass of 85 grams. So there's silvery metal on a scale, and it weighs 85 grams. And you are told that there is 1.3 moles of that metal on the scale. And we could then use this to identify what it is based on its molar mass. So we would just take our grams, 85 grams, divide by moles, and that will give us how many grams are in 1 mole. And so if I plug that in, 85 divided by 1.3, I get 65.38 roughly, or 65.39 grams per mole. Now, if I wanted to look on the periodic table, I know it's a metal and it's a silvery metal, so I could look and see here, you know, I have a list of metals here, but I know it's like a silvery color. So it's got to be over on this side, and if I just kind of look at my masses, I see I've got two here that are pretty similar, but we know copper is not a silvery color, and zinc's molar mass is right on. So I could then identify and say that that metal is probably zinc. Okay. Now let's do another problem that might take like a little bit extra steps. Okay. So here it says you have 8 grams of an unknown gas, and it occupies a volume of 5.6 liters at STP. What is the molar mass? So we want to take grams and divide by moles. And we have that whole 8-gram business right there. However, we have 5.6 liters at STP. We don't have the number of moles, but we know how to convert from moles or from liters to moles at STP. So let's just quickly run that conversion. So 5.6 liters times, and we'll say, well, we know that 1 mole is 22.4 liters. And I get 5.6 divided by 22.4. I get 0.25 moles. Okay, so I'm going to take that amount and put it down here to calculate my molar mass. So if I take 8 and divide it by 0.25, or 1/4, it's the same as multiplying by 4, I get 32 grams per mole. So that's the molar mass of that unknown gas. Now, because it's a compound, we couldn't necessarily know exactly what gas that is, but we could, from a list of gases, figure out which one it is by matching the molar masses. So let's just figure out the molar masses of each of these. Oxygen is 16, so times 2 is 32 plus 12. This is 44 grams per mole. Oxygen's 32 grams per mole. Carbon monoxide is 28 grams per mole. And nitrogen is also 28 grams per mole. So most likely, if I were to choose, if it was one of these gases, it would be that unknown sample of gas is oxygen. But notice that both carbon monoxide and nitrogen gas have the same molar mass. So if I had calculated my molar mass to be 28, then I wouldn't have had enough information to narrow it down exactly, but I could say it was one of these two gases. Right? So this is how we calculate the molar mass of an unknown substance.